ready. Today, we are talking. How many people did not print it out? Just so I know who to. Oh, okay. I'm watching for lots of people who are going to be writing everything. Okay. Today we are talking about variation models. We have 3 variation models. We have direct variation. We have joint variation. And we have inverse variation. Let me zoom in.
Yeah, do 2 slides. No, wait, hold on. I got you.
No, sit back down. We're taking notes, you goob. Okay.
Put it like after it.
So, when we are doing direct variation, the problem is going to say something like y is directly proportional to x. And we're going to see something like y equals k times x. Y equals k times x. That's direct variation. That is something that's like a linear function. This is like the slope. Y equals k times x. Yes. It's going to be easy to start with, and then as soon as we start doing math, you're going to have a hard time typing it. So I'd rather have you handwrite it, because it's going to be easy to type it first, and then it's going to suck to type. Yeah. I say that from experience because I know how to type math, and it took me many years to get fast at it. So, all right. So direct variation, y is directly proportional to x. Then we have joint variation. Y varies jointly as x and z, which is y equals k times x times z. And then inverse variation is y is inversely proportional to x. Y equals k over x. So this is similar to the idea that we studied yesterday with rational functions. And in all 3 of those, k is called the constant of variation. It is not a variable in the problem. It is going to be a number in the problem. It's going to be a coefficient, okay? It's called the constant of variation. Okay, so for the set of examples that we have, and this is Gina, so we have lots of them, the instructions say to just figure out whether the equation is direct, joint, or inverse, and then to identify the constant of variation. So we're going to say what k equals, and then we're going to say which one it is, direct, joint, or inverse. And you can write, I would write the directions down, but you can shorthand them. All right, so whenever we write examples, we should always say what the directions were, so that if we are to do this on practice problems, we know what type of directions we might see that would make us answer a question a certain way. Okay, so number 1 says y equals 2x. is that direct? So you can tell because in your equation. And then what is the k value for this problem? K equals 2. Okay. Number 2 says y equals 24 over x. Is that direct, joint, or inverse? Inverse. And what does k equal? K equals 24. All right, number 3, y equals 5 times x times z. Is that direct, joint, or inverse? Joint. And then what does k equal? 5. Okay. And 4, the y is not alone, so we have to get the y alone. So what should I do with the 3? Divide it over. So I'm going to divide by 3, divide by 3. So y equals x divided by 3. X divided by 3 is the same as 1/3 times x. X divided by 3 is the same as 1/3 times x. So is this direct, joint, or inverse? Direct. And what is the k value? K is 1/3. Okay. All right. Let me know if I go too fast, okay? In number 5, the y is not alone. So what do I need to do to get the y alone? Divide by x. So y equals 36 over x. Now, is that like number 4, or is that different from number 4? Should that 36 be a coefficient, or should this stay as a fraction? Should stay as a fraction. How is this different from number 4? It's instead of the denominator. So the 36 is divided by x instead of the x being divided by 3. Yeah. So x divided by 3 is saying that the x is being divided. So it's saying that x is what you have 1/3 of. Here, the 36 is being divided by x, so the number is what's being divided instead of the x being divided, which is why it's not a coefficient. It's not telling you how many x's you have. So over here, it was telling you how many x's you have. Over here, it's not. That's what's different about the problem. Okay, so we have 36 divided by x. Is that direct, joint, or inverse? Inverse. And what is the k value? K equals 36. Okay. All right. In number 6, the y is not alone. How do we get the y alone? So we could divide by 4/3, which could be tricky because it's a fraction, or we could multiply by 3/4. What would you guys rather do? The 3/4 way is a little bit easier. So times 3/4 times 3/4. They both accomplish the same thing. It's just about what is your comfort zone. So 4 on the bottom, 4 on the top cancel out. 3 on the top, 3 on the bottom cancel out. We just get y. And then 3/4 times xz equals 3/4 xz. Okay, so is that direct, joint, or inverse? Joint. And what is k? K equals 3/4. Okay. All right, number 7, let's get the y alone. What do we do? Multiply the x over. So we have y equals 2/5 times x. Is that direct, joint, or inverse? Direct, and what's the k? K equals 2/5. Okay. Number 8 says 2a equals b times h. Can you tell which letter is probably like the y? The a. Can you recognize what this is getting at? What formula is this kind of like? Triangle, area of a triangle. Okay. So what if the a is kind of like the y, and this is kind of getting at the area of a triangle, what should we do to make this formula correct? Divide by 2. Okay. Do you guys want to leave it as base times height divided by 2, or do you want to rewrite it somehow? It's fine the way it is. Want to rewrite it as 1/2. So think about in the context, not the context of what you're comfortable with the formula, but what context would help us recognize the k value. So we have to say whether this is direct, joint, or inverse, and then we want to recognize what the k is. So should we leave it the same or should we rewrite it? Karina, what do you think? Okay, so if we write it as 1/2 times BH, then is this recognizable as direct, joint, or inverse? This is joint, okay, and what's the k value? 1/2. So we can see the BH is kind of like the XZ, the A is kind of like the Y, and then the 1/2 in the front is the K, right? How comfortable are you guys with those? Pretty easy to recognize, yeah? Okay. Let's go ahead and we're going to switch over to the graphic organizer. If you guys printed that, it looks like this. Looks like this. If you did not print it, it's not a big deal. The idea of this is almost like you're making a cheat sheet, kind of, for like all 3 of these. That's the idea behind it, is that you're making like one sheet that you could look at. Okay. So if you're doing this on notebook paper, maybe get out a fresh sheet of notebook paper. So this would be something that you could refer to off to the side if you wanted to have like one perfect example of each of these just to look at. So we're making a chart. And on the chart, we're going to have the 3 different variations. We're going to have direct, inverse, and joint. They switched the order, but that's okay from what the other sheet was. And then we're going to have an equation, an example, a graph, an example in words. So this is going to be kind of like the parent function of the equation. This would be like an example equation, then a graph, then an example in words, and then this is not part of the chart. This is a combined variation, just so we can kind of see what that is, okay? So for the equation, we're just going to write out all of these. Direct variation is y equals k times x. Inverse variation is y equals k divided by x. And then joint variation was y equals k times x times z. Okay. For the example, I'm going to do y equals 2x, and then y equals 2 over x. Okay, so y equals 2x, if we were to graph that, does anyone remember how to graph that? Y equals 2x? So wait, where do we start? 0. Okay, so we're going to start at 0. And then what's our slope? Okay, when we go over 1, do we go to the right or the left? Right, okay. So we're going to go up to right 1, up to right 1, up to right 1, up to right 1, and then we can go the opposite direction. Okay, and then we're going to just draw that. So direct variation is linear when you graph it. Y equals 2x. Okay, and then inverse variation, we did that yesterday. Graphing calculator is going to be helpful. What do we graph first for inverse variation? Anyone remember from yesterday, what would we graph first? Vertical and horizontal asymptotes, right? So we're going to have on the bottom, that would be a vertical asymptote of 0. On the end, that would be a horizontal asymptote of 0. So I'm going to draw those asymptotes in. There is a cat hair in my mask, and it is tickling my nose so bad. Okay, and then we're going to grab our graphing calculator. Two over x. Okay, so there's the asymptote. Got the point -1, 2, -2, 1, -3. Oh, those were negative. -1, -2. There we go. 2, -1. Okay. Okay. How are you guys doing? Good with that? Okay. Then over here for joint variation, I'm going to write y equals 2xz. Now, when you write this, to make sure it's not confusing, either put a loop in your 2 or cross your z, do something so that your 2 and your z do not look the same. This is why a lot of math people cross their z's, so they don't look like 2's. But do something on this, since this is going to be kind of an example of everything, do something so your 2 and your z do not look the same. Okay? So 2xe. We're not going to graph that. Any idea why we're not going to graph that? Yeah, we got a z-axis. That's a 3D drawing, and I don't know about you, but I'm not very good at drawing in 3D. Some of you guys could probably do that, but I cannot. Okay. Everyone good? We got our example, so now we know what the equations might look like, and we know what a picture of the graph might look like. So now we're going to solve a problem where they're asking us to do it in words. Okay. So go ahead and take a second and write this down, and I want you to write all the words, and I don't want you to shorthand it because I want you to have a really good example of what it looks like when they write out one of these problems. So I'm going to zoom in so you can see all the words. And if you did not get a chance to print this, I want you to write all the words out for all, for this one, so you have a really good example of this, okay? Because I think these are worded kind of weird. Most of us don't talk like this, but this is how they word these types of problems. So it would be good for you guys to have an example of this on your paper if you did not print these notes. So we are actually going to write all the wording down for these examples, just to have a perfect example down. So it says, if y varies directly as x, and y equals 10 when x equals 14, find the constant and write an equation to represent the relationship. When they say find the constant, what do they mean? Find k. They mean find k. All right. So whenever you see those words, if k or if y varies directly as x, whenever you see that, you're going to write y equals kx. If y varies directly as x, whenever you see that, you're going to write y equals kx. And then they give you a y and an x to plug in. So if they give you a y and an x to plug in, that means you have enough information to solve for k. Because you have 2 letters, that gives you enough information to solve for the third one. So we're going to plug in 10, we're going to plug in 14, and we're going to use that to solve for k. So if I plug in 10 and I plug in 14, how do I get the k alone? Divide by 14. So what is 10 divided by 14 when I simplify it? 5/7. Okay, so for this equation to look like a direct variation, all that I need is to have the number in front of x. As long as I have the k value, the number in front of x, that means that I have a direct variation equation. So now I can write y equals 5/7 x, and there's my direct variation equation. Hello.
What group do you have for cats? 11. How many people do you have? And then I'll leave you alone. Sorry, everybody.
You're fine.
I'm the worst.
This is my attendance.
Thanks.
All right, go ahead and write this one down. If y varies inversely as x, and y equals 4 when x equals 12, thank you. Find the constant and write an equation to represent the relationship. So if they say that phrase, y varies inversely as x, then you're going to say y equals k over x. You're finding the constant, you're finding the k value. And so that means we're going to plug in y, we're going to plug in x. And what would we do to solve for k? Multiply by 12. And what is 4 times 12? Okay. So we're going to have y equals 48 over x. All right, last one to write. I lied, there's two more. This one and another one. Me too, Seth, me too. If y varies jointly as x and z, and y equals 42 when x equals 9 and z equals 7, find the constant of variation and write an equation. So we have 42 equals k times 63. All right, and then what do we do? Can you reduce 42 over 63? So they both divide by 7. And then 6 over 9 reduces again, right? Okay. So we have y equals 2/3 xz. Okay. All right. There's one last type. Dun dun dun. It is combined variation. Oh my gosh, Ms. Rice, why? What do you guys think combined variation is? It is a combination of direct and inverse variation. A combination of direct and inverse variation. I guess they don't include joint in that definition because joint is very similar to direct, maybe? I feel like joint is like direct with direct. It's direct in itself, yeah. All right, So this one is going to be really interesting for us to figure out, but I think we can do it. Okay, I know you guys are probably sick of writing, but we're going to write one more. And this one is funky. This one is strange. Can I zoom out any more? This is, okay, hold on. I got to zoom out with this. Focus. Is it? Come on. Come on. There we go. Okay. It says if P varies directly with Q squared. If P varies directly with Q squared, and inversely with R. If P varies directly with Q squared and inversely with R. And P is 38.4 when Q is 8 and R is 5. P is 38.4 when Q is 8 and R is 5. Find the constant and write an equation. Okay. How do you guys think we should start it? Wait, before we plug numbers in, we have to find our formula kind of thing. So how do we write P varies directly with Q squared? P equals, I don't quite agree with that. We need a K in there. K. Okay, so this is P varies directly with Q squared because we need the K. Yep, you always have to have that constant in there. And then how do we have and inversely with R? Divided by R. And inversely with R. There's our equation. Does that make sense? So here's the KQ squared is the directly with Q squared. The K over R is the inversely with R. Does that make sense? Nope. I mean, it is. Directly with Q squared, inversely with R. Directly, inversely. Okay, so now we can go ahead and plug our numbers in. So P is 38.4. K is the constant we are solving for. Q is 8. R is 5. Okay. We can multiply by 5. All right, let's see. 38.4 times 5. So that's 192. Okay, and then what should we do? Oh, that divides evenly. So what does K equal? 3. Okay. So now what do we do? Just plug a 3 in. P equals 3 Q squared over R. All right, how do your brains feel? Mush? Okay. This is going to be like your little cheat sheet to kind of refer back to anytime the wording of a problem messes you up. Okay? because we had the wording on here so that we kind of knew how the problems were going to be worded. So now let's go through and do some more problems just to practice it, but you don't have to write the wording down for these ones. Okay, we're just going to practice. Yeah. Will you pull the door closed behind you so it's more quiet in here? Okay. So we're going to practice these, but not writing down all the problems. So here for these, you don't have to write down all the wordiness. You can just write direct variation examples for those of you who are doing these on notebook paper. So for this, you're just going to put direct variation examples. Direct variation examples. And then all you need to do is write y equals 28, x equals 7. Y equals 28, x equals 7. And then write x equals question mark when y equals 52. X equals question mark when y equals 52. Okay, so let's go ahead and split this in half. So what we're going to do is we're going to start off by writing the equation. So what's the equation for y is directly proportional to x? What's the equation? Y equals kx, okay? And so now we're going to use the first set of information they gave us, okay? So they gave us that y equals 28 when x equals 7. So we're going to do 28 equals k times 7. And what is this going to help us do? That first set of information helps us do what? Helps us find k. So how do we find the k? Divide by 7, divide by 7, and k equals 4, okay? K equals 4, so we end up with y equals 4x. So there's our equation. So now we can go to the other half of the problem. Y equals 4x is what we're starting with. Now we can use the second half of the information. So we use the first half of the information to find the constant, to find k equals 4. Now we're going to use the second half of the information to find x when y equals 52. Does that make sense? So now we're going to find x when y equals 52. We're going to say 52 equals 4x, and we're going to find x. So what should I do now? Divide by 4, and then what's 52 divided by 4? 13. So x equals 13. So 2 halves to the problem because they gave us 2 sets of information. Does that make sense? Okay. Okay, so this says r is directly proportional to the square of s. So how do we write that? But we're gonna do R instead of Y, right? Because it says R instead of Y is. So R is K to the square of S. Okay. And it says when R is 72 and S is 12. Okay. So the first half of the problem, we're going to find K. The second half of the problem, we can deal with the second half of the information. Does that make sense? Because they gave us two pieces of information. R is directly proportional to the square of S. Are we comfortable with that? Okay. So R is 72. We're finding K, and S is 12. Okay. What's 12 squared? Okay. So what's K? All right, so what is our equation? Okay. All right, so what do we do now? Find R when S equals 8. Replace the S with an 8. So R equals 1/2 times 8 squared. So R equals 1/2 of 64. R equals 32. How do your brains feel? Brains feel good? Okay. Okay. So for this one, those of you with notebook paper, you're just going to write $148.50 for 18 hours, $90.75 for question mark hours. That's all you have to write for the next example. For notebook paper people, you're going to write $148.50 for 18 hours. $90.75 for question mark hours. Okay. It says the amount D that she earns varies directly with the number of hours that she works. So D varies directly with the number of hours that she works. How do we write that equation? D equals KH. Okay, so again, we're going to divide this in half. Let's use the first piece of information. How do we do that? D is the dollar amount equals K times H. H is the hours. So what do I write? Okay. So we're going to divide by 18. And K equals What does that mean if we got K equals 8.25? She must make 8.25 an hour. Okay, so D equals 8.25H. Okay, and then what do we do over here? So we're plugging in the dollar amount, putting 8.25H, and we're going to solve for H to see how many hours she worked. And then what are you guys getting for her number of hours? 11. Okay, so I think that what I'm going to do, I think I've given you a lot of information today. So I think that what I'm going to do is let you guys, we're going to stop here. And I think that I am maybe going to let you guys do the first worksheet that looks like this. That's this at the top. And do problems 1 through 12. Does that work? We'll start that today, and then tomorrow you can finish the notes. When the sub is here, I'll have you guys finish the notes and then do the rest of the practice assignment. Does that feel reasonable? That way I'm not overwhelming you. What? So today we'll do 1 through 12, and then tomorrow I'll have you guys finish the notes and then finish the practice assignments. So tomorrow you'll just have to do this last page of notes. Does that sound reasonable? Okay. Let's do that since we only have 35 minutes left of class.